Is everybody good to there? All right. Then I have, so what I have done is x to the 1 plus 2. Now I got to do my y's. Negative 4 plus 5, which is what? Y to the 1. Yeah? All right. Now, down here. I recommend leaving my negatives till when? The end. So, negative 2 to the negative 5 would be negative 2 to the negative 5. And I know I've said leave the negatives till the very end, yes? All right. X to the negative 5 and y to the negative 15. Okay. Now we do numbers separate from letters, yes? So we are going to leave those numbers because they get tricky. What do I do with the x's? 3 minus 5. What's that? 3 plus 5, which is x to the 8. I'm happy he's positive. 1 minus 15. Y to the 16. Positive, I'm happy, yes? Is everybody good? So now it's just the numbers that are going to cause us grief, yes? All right. What happens here? Let's do it this way. Are these the same base? But there was a bracket around it. So it's written weirdly, right? It's written kind of trappy, right? Because you kind of see the same base, but it's not really the same base. Because this is really negative 2 to the negative 5th, isn't it? Okay. So what else can we do here? Because we know there's a 2 living up top, right? Okay. What else can we do? What don't we like about that? Okay, so where does it have to go? So can I move him up here and make him positive? Okay, so what is negative 2? Why is he still negative if I moved him up? Because he's a base. Bases don't change. So what does he become? What's 2 to the 5th? Negative 32, right? Because it's negative 2 times negative 2 times negative 2. It's got an odd exponent, so it's going to stay negative, yes? So I have negative 32 up top, positive 2, x8, y16, right? Is that all okay? What do I do with 2 and 32? Multiply it out. Of course you have to keep the negative. But it's not negative 32 times negative 32. It's negative 32 times 2. I have y to the 16. I just didn't finish the 6 very well. Everybody okay? Now, could we also, since this is, it ended up being negative 64, yes? Is negative 64, that's just 2 to the 6th, isn't it? Right? So now look, what was this 2? It's 2 to the 1, right? What's 1 minus 5? 6, 2 to the 6th, and then there was a negative out in front. So I could have still done the base rules. Gouda? Gouda? Great. Davneet? Oh, sorry, Shotzi. Yes. Anything else from the really hard exponents sheet? What made it really hard? Nothing really, right? I changed the alphabet order sometimes. right? I put some 0 exponents in there, but what do you get to do with every 0? They don't count, right? Everybody okay with it? Everybody was able to understand how the answers were gotten? Yes? And you're all aware that this really hard exponent sheet that I gave you is harder than everything that will be on your test. Way harder. And so if you could do that, how should you do on your test? Great. Yes? All right, everybody good? When do we have our test? Never. When do we have our test? Well, I know it's sometime this week. I'm asking you people. I'm asking you. That's what asking means. I don't care. No. I am asking you when you would like to have your test. Friday? No. It is not going to be next Monday. It is happening this week. I'm hearing lots of Wednesdays.
Friday.
Wednesday's a good day because it's second block.
Friday.
Yeah, let's have it Wednesday.
Bonus quest. What's the date? Wednesday. Today's the 1st, 2nd, 3rd. May the 3rd be with you. All right. Let us move on, cabbages. Your next page is polynomial multiplication. Everybody. Now, polynomials got a little weird in the printing. Now, guys, I am going to go fairly quickly here, and I'm not going to be very exhaustive, meaning there is stuff that some people in the mathematical world feel that you need, and I am not one of those people. So I am not going to spend a lot of time with that stuff. Okay? So we are going to gloss over some of these notes. And we are going to take longer with some of the other notes. But the warning I wish to give you for this unit is the practice is absolutely, positively necessary. Because you will notice when we get to it, there is not a lot of extra work to do, because this is one of those things that it doesn't matter what numbers I use. You follow the same sets of rules. Understand? So, for you guys, I don't know what page this actually is, because I have it as page 1, because I have it on my screen as its own thing. So for you guys, it's page 141. Okay. All right. This is review from grade 9. You already know all the answers on this page, so I'm going to go over it very quickly. All right. The important thing here is I'm going to use, as always, the proper mathematical terms. So you do need to know them. So as we go through this unit and discuss them, when I say the word coefficient, you know what I mean. All right? Okay. So let us do this thing. A polynomial is a math expression. A math expression. Forgot the E. Which is a combination which includes coefficients, variables, and constants. Okay, I'm going to highlight those three things with different colors because I'm going to come back to that in a minute. What it doesn't contain, no radicals. If there's a radical, you do not have a polynomial. Okay? Now before I go any further, I'm going to ask you this. Is this a polynomial? Look at it closely.
Who are those two people I said?
These two. Caden and Kayla. You guys going to this? You're not going to go? Okay.
You're Caden?
He's Kaylin.
He's Caden.
He's Caden.
You got the other one too?
So, is that a polynomial? Many of you all said no. Why? What about that made you immediately say no? You saw a radical until I said look closer. What is it really? What's the square root of 4? 2. So isn't this 2x? So is that a polynomial? Yes. Everybody understand? Okay, good. Now, a coefficient is highlighted in yellow. So I'm going to write 4x squared minus 5. What's the coefficient? 4. What's the variable? X, only the x. What is the constant? There's only two things left there unhighlighted. What's the constant? Five. Because what is 5? 5. It's nothing but 5. It's always 5. Therefore, it is constant. Okay? This 4's value depends on what x is, doesn't it? Right? Everybody cool? Okay. A monomial. I'm going to highlight that because that's a word I will be using constantly. We've already used it this year. A monomial is any single coefficient variable or constant. Single is the word there, and they can be connected by multiplication. Or division. What do I mean by that? This, 4x squared. That is a monomial. Why? Because it's got a coefficient and and a variable, and it's connected by multiplication. Cool? X over 4. Monomial, because that's really 1/4 times x. Multiplication. Cool? 3x squared y squared z to the 5th. Still a monomial because it's all multiplied. Got it? All right. A binomial, which is the second one, is any combo of two monomials. So, 4x plus 7. Monomial, monomial, combined. Right? 3x squared y to the 8th plus 4qp. Binomial. Got it? Right, that's the next thing I'm going to write. Adding and subtracting separate what we call terms. Trinomial, guess any 3 monomials. Separated by what? Separated by adding or subtracting. Everybody cool? Easy peasy. This word, degree of polynomials, might be new to you. The degree of polynomials, we really only use it to write down our right answers. Okay? The degree of polynomial is simply this. The highest sum, please highlight the word sum, of variables exponents in any one term. So here's what I mean by that. 4x. What's the variable's exponent in that monomial? 1. So that is a first degree polynomial. Everybody good? Everybody good? Okay. 4xy. What are the variables there? What are the variables? X and y. What are their exponents? 1 and 1. And degree is the sum. So what is that guy? 2. That guy's a first degree. That guy's a second degree. Everybody with me? Okay. 4xy squared plus 3y cubed. What degree is that polynomial? No. In any one term. So it's still a third degree because they're both 3. Everybody got it? Okay. What about this? 4x squared, y squared, z squared plus 1. What's that guy's degree? 6. Everybody good? Okay. Then the rule. And please remember, I don't really care about this. When we write polynomials, we start descending degree and or descending exponents of x. Okay, so what does that mean? Alphabetical. Biggest degree first. But again, I don't care. In a perfect world, we would do this, but I don't care. I care more that you get the exponents right. Understand what I'm saying? So let me show you what I mean. You don't even need to write this down. 3x squared y cubed plus 4x to the fourth y to the third. Is that in the right order technically? Descending degree, descending exponents of x. What's the biggest x value there? X to the fourth. So really, I should have written this as 4x to the fourth y cubed plus 3x squared y cubed. I don't care. Okay? Somebody later might, so I've done my job to show you that. All right. Do I need to make you do this? What does this mean in English? 5 groups of what? Of x plus 1, yes? So if I drew x plus 1, x plus 1, how many times would I need to draw? 5. 1, 2, 3, 4, 5. And what would the answer be? 5x plus 5, right? The product lives in here, and the factors live out here. One, 2, 3, 4, 5, and x plus 1, right? Everybody remembers this from the 9th grade? Good, because I really hate using them. Algebraically, 5x minus 1. What is that really? 5x's minus 5 times 1, which gets me 5x minus 5. Yes? All right. That, ladies and gentlemen, is the distributive property. It works all the time. A x plus y plus z is ax plus ay plus az. How long can that go on? Forever. As many terms as I have in here, they all get multiplied by a. What happens if a is negative? What happens to everything inside? It switches. Negative ax minus ay minus az. What happens if it's a mixture inside? Negative ax minus y plus z. What do I get? Negative ax, positive ay, negative az. Can everybody distribute? And I do not need to draw it, I hope. So, this question here, I am not even going to do a picture. Algebraic only. So, what does that mean? Does this look exactly like that? There's a coefficient out front. It's multiplying into another polynomial, yeah? So, what is my first? It is x times 2x. If we were in the 9th grade, I would make you write that. We are not in the 9th grade. We are in the 10th grade. Can we do that in our heads? What is it? 2x squared minus x times 4, which would be minus 4x. Yeah? Easy peasy, lemon squeezy. Do this in your sleep. Right? Good. Next, I'm not going to do a picture. What is the algebraic solution? The first term is 3x times x. What is that? 3x squared. Plus 3x times 2. What is that? 6x. Is everybody good? All right, we are cruising along nicely. Binomial by binomial. We've already done this once this year, right? Some of you had seen it last year. This one I actually want to draw. I have my reasons. These are both factors, yes? So where do they go? On the outside of a rectangle, right? X plus 3. 1, 2, 3. The other side has x plus 2. And then I multiply it out. X squared, yes? Because that x is stretching all the way out here. Then 1x, 2x, 3x, 4x, 5x, 1, 2, 3, 4, 5, 6. That's my product. And it is x squared plus 5x plus 6. Yes? Everybody with me? All right, now, all of you want to pay very close attention right now because a great many of you on your radical quest screwed up doing this. X plus 3, x plus 2. What is that really? That is really x times x plus 2 and 3 times x plus 2, isn't it? So in red, I get x squared plus 2x, don't I? In blue, I get 3x plus 6, don't I? Now, if I do this, what can I do with 3 and 2? Add it up because they're like terms. Is everybody cool with that? That sets up what you guys know of. Some of you knew before than I showed you. It sets up this acronym, FOIL. First, outside, inside, and last. So, x plus a, x plus b. First, we'll do in black, x squared. Outside, we'll do in red, the outside 2 plus bx. Third, we'll do in blue, the inside 2 plus ax. I put the x's together and I start a second row. You'll see why this is useful in a minute. And last, I'll do in green, the last 2 plus ab. When you set it up this way, you know your like terms are already together, and you can just put them there. X squared plus a plus b x plus a times b. Everybody cool? So this question should be able to do in your sleep. X squared plus 4x minus 1x minus 4. X squared, what's 4 minus 1? 3x minus 4. There's the answer. Good? So it should take you about 30 seconds to do this next page for you guys. You do not need to do pictures. Everybody got the first two, yes? If you did not get the first two, then you are somebody who might want to consider actually drawing the picture once or twice until you get it. Is everybody okay? Going once, going twice, going thrice. Gouda. So, multiply algebraically 4x squared plus 8x minus 8x minus 16. 4x squared minus 16. This is the one that I was worried about. I hope that all of you recognize what the base is here. What is the base in B? X plus 2. And that whole base is squared, yes? So this is really x plus 2 times x plus 2. It is not x squared plus 4. Because what it really is x squared plus 2x plus 2x plus 4, which is x squared plus 4x plus 4. Gouda? Great. And let's finish these up. It will only take a second. X squared minus 2x plus 3x minus 6. X squared plus x minus 6. X squared minus 7x plus 9x minus 63. X squared plus 2x minus 63. X squared plus 4x plus 9x plus 36. Plus 13x plus 36. And x squared minus 4x minus 2x plus 8. X squared minus 6x plus 8. Was everybody good to there? Now don't turn the page because I told you I was going to give you a gift. What do you notice about everything I have highlighted in blue? Something is in common. What is it? There's always an x with no coefficient, right, Max? Yeah. Excellent. Now, look at what I'm highlighting in yellow. What are you noticing? I'm going to do a little bit more highlighting because what are you noticing when I do this yellow highlighting? Those become the coefficient of the middle term, don't they? Everyone agree? Okay. Now, what about what I am highlighting in green? What do you notice about what's green? They multiply. So, the shortcut gift that I am giving you is when you have x plus a and x plus b, as long as they're x's, then you know the answer is x squared and then a plus b, x, and then a times b. Every single time, as long as it starts with a single variable. Okay? So if I gave you this, x plus 3, x plus 4, what's the answer? It should take about 10 seconds.
X squared, 7, 12.
What if it was m plus 7, m minus 3?
M squared, 4x, negative 1.
Got it? Yes. Okay, that is my present to you today. My mathematical present. Your job is to do, and this is all you are going to do, your next 2 pages. I call your attention to specifically 2 things. Look on page 145. Look closely at E and F. They look different. Do the rules change? No. And you are going to do page 146 as well. And you are going to pay special attention to K and L. They will cause you grief. 145 and 146. That is your work for tonight. Tomorrow, we will be taking what you learned from multiplying and applying it to something that for many of you will be completely and totally new. And it will appear completely and totally useless. In real life, yes. In math, no. It's one of the most important tools you will ever have. I'll give you an example. If you need to build a house, what is the simplest tool that you can think of?
Hammer.
A hammer. Can you build a house without one? No, but it's probably the easiest tool to use, isn't it? All of you can use a hammer, can't you? Could you build a house without one? No. But you can all use it, yes? Is a hammer useful in real life? Right today, have any of you used a hammer? No. Have I? No. Do I know how to use it? Is it good that I know how to use a hammer? In case I need to hammer something. So, tomorrow in your real life, when you leave this place, will you do the math that we teach tomorrow? No. But will it be a good idea to know how to use that mathematical tool? Possibly. Just like you all know how to use a hammer. Even though none of you will use a hammer today, or very few of you. But you all know how to do it. Right? Just like you all know how to turn a doorknob. It's a good idea to know how to do stuff just in case. Right? Mommy and Daddy don't make you dinner tonight. You're not going to starve because you know how to use the stove and the microwave. That whole real life thing really gets under my skin. It makes me extraordinarily angry. Miss Riaz.
The shortcut under what condition?